Welcome to Maths for All. I'm Aisling Flynn. This is Higher Level. We're doing calculus, differentiation by first principles. So what we're going to be doing is finding the instantaneous slope. And this is the general process. So we begin with a blue line that starts at A. And this line is used to approximate the red curve. And to get the instantaneous slope at point A, we're going to shorten that blue line and bring the slope of the blue line closer to that instantaneous slope at A. Okay, so remember that slope is rise over run. So in the first diagram, we get a slope of delta y over delta x. Okay, and it would give some indication of the slope of the red curve. But to get a better approximation, what we should do is make delta x smaller and smaller and bring this point, second point on the red curve, closer and closer to A. So the second picture here would give a better indication of the slope of the curve. And the third one here indeed is getting very close to the instantaneous slope. The blue line there is lying pretty well matching the red curve. But what we want to do is we want to arrive at a situation when the change in x is basically 0. So we're looking at it as delta x approaches 0. As delta x gets smaller, we get closer to the instantaneous rate of change. So, and in mathematical notation, delta y over delta x becomes dy dx, the derivative for instantaneous slope, as delta x approaches 0. First principles. So we're going to attempt to do what we saw in the first slide there by first principles, and we'll go through each step. The first step is to examine the vertical difference, okay, to give us the rise part for our slope. And we're going to use this graph to help us. Let's first examine the x-axis here, and we have points x and x plus h indicated, and they give me the x values of point A and point B. Point A and point B are the endpoints of that red line which is approximating our blue curve. And the idea will be to make B basically come back to A so that our red line is essentially a point and we get the instantaneous slope. For points A and B, they have the x values of x and x plus h, and their y values are here on the y-axis, and they are f of x and f of x plus h. Okay, and so I'm going to begin by just drawing some lines here so we can see more clearly what will be our delta y and our delta x. Okay, so we're going to write the vertical difference first. So delta y, which will be the difference from the y value from point B and the y value of point A. So it will be f of x plus h minus f of x. Okay, that is your delta y. Now delta x will be simply the differences in the x values, so x plus h minus x, which is just h, so that's our run, is just h. Okay, our run will be h. So now we're going to use those two things to write the slope of the red line, AB, and okay, so slope of course is rise over run. So if you recall from the previous slides, the rise is the difference in y values, f of x plus h minus f of x, and the run is just h. Now, what to do with that? Well, we have that expression for slope. I'm going to write it out here again. Alright, that was what we had. And basically our slope will be, so to change delta y to delta x, we use dy dx will be the limit as h goes to 0. So as point B goes back to point A, as h gets smaller and smaller, as x plus h goes back to x. So the limit as h goes to 0 of f of x plus h minus f of x over h. Alright, and this is the definition of our instantaneous rate of change. Okay, so that's the idea, and now we have to put that into practice, and it comes up very, very often in the exams. So a summary of steps. These are for when in an exam you're given an expression and asked to differentiate it according to first principles. And we only do it when we're asked for first principles. So the steps are to firstly write down your f of x, then write down your f of x plus h. So using x plus h as your input into the function where x was in step 1. And then you subtract. So remember that this gives you your delta y, your rise. The next step will be to divide by h, which of course was delta x. So this is giving you your slope. And then you have to use your knowledge of limits. You're going to find the limit as h goes to 0. And that will give you your dy dx. Okay, so let's do an example where we put all those steps into practice. This question is from the 2020 Leaving Cert Higher Level Paper 1, and it asks us to differentiate 3x minus 5 times 2x plus 4 with respect to x from first principles. So the only time you actually go through these steps are when they're specifically requested and the words first principles are used. Firstly, here's my expression. At first sight, you might be thinking something like product rule because you have a multiplication, but for first principles I would start by multiplying those two brackets and having one single polynomial. Okay, so let's do that first. So 3x minus 5 multiplied by 2x plus 4. Beginning with the 3x and multiplying it by the second bracket, we get 6x squared plus 12x. Then multiplying by the minus 5, minus 10x minus 20. Okay, and simplifying the two middle terms, we get 6x squared plus 2x minus 20. And that's our starting point. Okay, so one useful thing about this is that you can predict the answer that you should get straight away, and it's worth noting it. If we differentiate that expression, we know that the answer should be 12x plus 2. So if we get that at the end of the question, we know we've done okay. So the expression represents f of x. So that's the first thing we'll write down. F of x equals 6x squared plus 2x minus 20. Now that's the first step. The second step asks us to write down f of x plus h. So that's our input for the function. So everywhere above where you saw x, now you will have x plus h. So 6 times that squared plus 2 times x plus h minus 20. Let's multiply and expand out these brackets, see what we have. So it'll be 6 times. If we square this bracket, we'll get x squared plus 2xh plus h squared. Multiplying the 2 by the bracket, you get 2x plus 2h, and we'll have minus 20. And lastly, I'm going to multiply that 6 there by the 3 terms inside the bracket. 6x squared plus 12xh plus 6h squared plus 2x plus 2h minus 20. So that's quite long. Okay, now the third step asks us to find basically what is the vertical difference, or delta y, f of x plus h minus f of x. So that's what we're going to do now. I'm just going to use a different color to illustrate. So from f of x plus h, I'm going to subtract f of x. So subtracting f of x, I'll be doing minus 6x squared, and I'm just going to write them under the similar terms. I have a 2x, so I'm going to subtract 2x, and I have a minus 20, so I'm going to do minus 20, which is plus 20. Is that okay? So have a look there and review at that, make sure you're happy. So what will this give me when I combine that with the f of x plus h above? I will get f of x plus h minus f of x equals, so 6x squared minus 6x squared is 0. What remains is 12xh plus 6h squared. 2x minus 2x is 0. I still have a plus 2h, and minus 20 plus 20 is 0. So now I've got the vertical difference, delta y, 12xh plus 6h squared plus 2h. Okay, and following to the next step. So we have to get the slope, which is the vertical distance or difference, over the horizontal, which if you recall was h. So we're going to divide the expression above by h. And let's see what we get. We get 12xh divided by h gives me 12x, plus 6h squared divided by h gives me 6h, plus 2h divided by h gives me plus 2. Okay, now the method then requires us to get the limit of this. So the limit as h goes to 0, remember we're making that distance closer to 0, of the expression that we just got, f of x plus h minus f of x over h. So what happens to this when we make h closer and closer to 0? All right, well, yeah, we have to get the limit of this. I should put in the limit there as h goes to 0, and the limit as h goes to 0 of the whole lot will be, well, 12x plus 6, well, h becomes 0, so we replace h with 0, plus 2. So you follow your method for getting limits. If there were more terms with h in it, you'd be dividing first by the highest term of h and then putting to 0. So what do we get for finish? We get our f dash of x, our instantaneous rate of change, is 12x plus 2. And we had predicted that, so we know that we're good.